Well, hi, and thanks for joining me here in my shop this morning. I'm going to be carrying on with the replacement of capacitors in here. Yesterday I replaced the questionable capacitors, if you will, in the audio circuits. Played the radio. Radio works really well. So today I'm going to replace the capacitors in the radio portion of this radio, the RF portion, and hopefully not ruin its operation, because it's actually working that well. It's working amazingly well. So now another big factor for me today is the weather. The weather is going to be very, very bad. Here, just going to flip this over. I think I'm going to pull this out. Put that in a safe place. There we are. There we go. So let's see, let's spin it around this way. Now, there's a number of capacitors in here of this sort, these black ones. I see 4 of them here, and there's probably another one hidden from view somewhere. At least 4 of them. At this point I'm going to leave those as is. I also have this capacitor here, which at a glance doesn't even look like a capacitor. I'm inclined to replace this, but for now I'm going to leave it. I'm just going to concentrate on 1, 2, 3, 4, 5 more. Yeah, 5 more capacitors in here. And then at that point we'll test the radio and we'll make a few measurements on the radio, try to determine if it's performing near its intended performance, which I'd be pretty surprised if it's not, because it's working pretty good as is. Any particular order to these? Let's see, this one's kind of buried, this one's a little tricky to get to there. The size of the original capacitor is big enough that that was actually a problem for the radio designers. You have to make sure the connection points are far enough apart in the radio for the capacitor to fit in between. Good. Okay. And for the sizes, wow, okay, so this one I think I can see 0.01 written right on it. Hopefully we can find the sizes written on them. Okay, away I go. Okay, so the challenge here is this has come out looking like a 0.1, but the numbers are obscure there. It looks like 0.1, it could be 0.100 or 0.1500. So I'm going to look on the diagram for the radio and see what's connected to this terminal right here. Okay, so the area we're looking at is right in here. We're looking at the tube base, and the capacitor I cut away was connected to this pin right here. We'll follow this line down here. Here it is, C12. Point something. C12. 0.1. Fairly good. Oh, that's C9. There's a way to make a mistake. I usually find it. There we are. Point something. Okay, so C12, we'll look at the parts list. Down here, C12. There it is. 0.1. Good. So a 0.1 capacitor there. Okay, so that's every paper capacitor of this sort. Why don't we give these guys a test. A couple of these I cut the leads off a little short, but let's see if we can still do it over here. Start with a small one. All I'm doing is just testing these for leakage. The last ones showed what I would call kind of medium degradation, I guess I could call it that. So watching the eye, 150 volts, opened right up. 250, still opening. So a very, very good condition capacitors, which is why this radio was operating. Very surprising to me. But what's not surprising is that they're all kind of in consistent condition. 50 volts. Okay, yeah. Now, some of these would be doing heavier duty in the radio than others. They'd be pressed by a higher voltage. So maybe those would show up a little more worn out, or maybe this radio has not. Yeah, this radio doesn't have much mileage on it. I think that might be part of the picture too. That was 150, right open. So probably changing these out, frankly, has had little bearing on the operation of the radio. This one, we'll test this one for its size too. Okay, leakage at 50, 150. Oh, not so good. So we found one that's actually not so good. Which one this is, I don't know. So one of the 0.1s in there was a little more leaky than the rest being really pretty good. So I think at this point where we stand with this radio now is all the most likely bad capacitors, which have turned out not to be so bad, have been replaced with brand new top quality capacitors. What's remaining in here, of course, is 1, 2, 3, I believe there was four of these guys, and a pile of resistors, which I paid no attention to at this point. So I think the name of the game now, you can play the radio. For sure we're going to get a good result. You know, unless I've done some egregious thing here, which I don't think I've done. So also it might be good now to start putting some instruments onto the radio to feed in some controlled signals. Let's try that. Let's try it. Oh, we didn't test this guy. Quick, long range test. $50 volts. Not quite open all the way. 150. So there's the bad actor. There is a bad actor. This is supposed to be good for 600 volts too, Sangamo. So interestingly enough, just look at the construction of these. Like, this is all sealed in a nice plastic can here. This is pretty thick too, from my experience. It's pretty thick. This guy's just cardboard with two rubber or rubbery plates on the end with the wire coming through. I cut one of these away the other day and there's really nothing in there protecting it. Yet this is in better shape than this. probably because there's something internally bad about this. And maybe the paper was cheap in here. There's some kind of contaminant inside the capacitor, actually, which over time exacerbates its badness, I guess would be what it would do. We're plugged in. Now, this is going to be connected to an outdoor antenna. Yesterday I had fantastic reception with this radio. Later in the day I checked it on my big shortwave radios to see if there was something great going on in the sky, but there really wasn't. It was just another kind of regular day here. Here, over this way. A regular day of shortwave, which isn't very good these days. It's really kind of bad because of the weakness of the sun. And the speaker. We need the speaker. So why this radio was picking up all kinds of stuff when my fantastic radios were not, may have just been the time of day. 6 hours later things are different, of course. Or it could be this is one heck of a good receiver from 1937. Just checking, make sure everything's good. Hello, Peanut. Yeah. Okay. He says, hey, put the camera on me. There he is, making his daily foray into my shop. Peanut, what's up for today? Some bad weather is coming, but it's rain. Rain is more like spring and summer. We've got about 2 feet of snow still outside. It's getting to be glacial. It's been out there for so long, it's getting very heavy and packed at the bottom. And rain's going to fall on it. 20 millimeters of rain, that's a lot of rain falling on top of the snow. And then it's going to be warm today, about 7 degrees, which is unusual to be 7 degrees here at this time of year. But then tomorrow it's going to be freezing again, so basically a disaster is coming here. Yeah, I know. Okay, I gotta turn this radio on. You want to do that, Peanut? Do you want to come up and see that? Turn on. I'll pick you up. Come on. Right here. Up you come. There you go. Here. Take a look in the camera there. Look in the camera. He doesn't know what I'm talking about, of course. Okay, enough with the cats here. After all, when you watch my videos, you are seeing me live my real life here. Yes. There he is. Okay. Do you want to get right on the bench? Go right on the bench. No, you don't want to go on the bench. He's a little scared. I'd be scared too. Okay, you ready? Are you ready, Peanut? You're gonna watch this now? Here we go. No action. There we go. What's going on? Do you want to go down now? Yeah, you're bored. Go on down. There you go. Go find Shadow. Play with the other cat. I bored him. Okay, radio. Super duper quiet. Huh? That's a bad sign. I mucked it up. Let's go on the other band. So now we're on the AM band. Where'd all the goodness go? Oh my. So isn't that something? I just turn this up. Yesterday I was picking everything you could think of up here. Not so much today. Wow. Don't change your capacitors. Well, we knocked the wind out of this radio. Let's try on shortwave. 6 megahertz. We're at the wrong end. 7, 8. Okay, up in here. Just noise, eh? Just noise. Well, Jim, you've really done it now. So you've taken this radio, which was working really well, changed 4 or 5 capacitors in it, and pretty much killed it. So either I've made an error, which I don't think I've done, or the radio is tuned up for the old capacitors. I put in new ones, and the tuning has gone off, the IF tuning or something of that sort. Well, let's start by pumping into it a known radio signal and just make sure it will receive. The fact that it's picking up noise everywhere, the same noise, just that put put put. I shouldn't say put put put. It's antenna noise for sure. It's not an oscillation in the radio. Well, I think that screams alignment problem, but hey, what if we give it full voltage? Maybe I'm making a big mistake here. It's running at 100 volts. Let's give it full. Maybe. Now, I have heard that sometimes when you replace the capacitors in an old radio like this, the B plus goes from some low value to its proper higher value, and at that point, boom, blows everything out of the radio. I don't think that's the case here. It's zero sensitivity. Like there's just, did I do something wrong with the antenna? Wow. Even with the antenna disconnected, it sounds the same. What did I do to this? What did I do to this radio? Something bad. Interesting. Okay, so when I connect this, I'm going to be connecting it into the real ground over here. I am the noise source. I am the source of noise. If I ground myself, everybody see that? You see what's going on there? So I am the unbolted piece of metal. I am the accidental floating piece of metal. Let's pretend. Me. And now I'm going to ground myself. Should get the same thing on the chassis. Exciting stuff, eh? Okay, lots of fun with radios. Now, let's put this on over here. So we have a fairly strong signal at 1450. AM band, 1450 out here. Yeah, it's on the wrong side of 14. Right around 1450. Okay, I'm going to knock down the signal strength. So what the radio's done in response is the radio's sensitivity has increased automatically. Let's go down another step. It's a very low signal at this point. Very low. Slips a little bit here. Can't hear it. So if this is calibrated here, that's still a fairly weak signal and the radio is receiving it just fine. So why didn't it pick stuff up on the rest of the band? What's the big difference between today and yesterday? Maybe the sensitivity down here is really, really poor. This is where the stations are, down at this end. Kind of got quiet, didn't it? Okay, so we're around let's say 660, something like that. Now that's the same low signal strength. It's receiving fine. Yeah, maybe my antenna, you know what, the antenna switch at the other end of my house may be set wrong. That may be the whole reason. Let's put it back on the antenna here. Okay, so I'm going to run down and make sure the antenna switches. The other end of my house is switched right. Lots of volume. Yeah.
Southwest winds, near 10 for the high tomorrow morning and falling for the afternoon. Few showers ending early in the morning and then more showers for Friday afternoon. Colder after the weekend, chance of flurries Saturday 0, sun and clouds for Sunday and Monday with highs near 1 or 2 degrees. For today, the guaranteed high +9. Downtown partly cloudy, 4 degrees, mostly cloudy and 5 at Pearson Airport.
So, +9 in Toronto. That's not up here. Okay, good. Radio's working again.
Everything that impacts move back to Justin. You're talking about that. The main reason I have parking because you're going to have to then take the extension of the subway, which is a bit of a joke because they do maintenance so regularly that you can't get there consistently.
610, 590.
Markets than we've seen. You know, someone pointed out to me one of the things that happens when the Yankees and the Red Sox decide to build from within is they got a lot of young players that are cost effective. They're not.
Might be Buffalo. Very weak there. Now, you hear that interference. We didn't hear that yesterday. There's a good chance the cause that interference wasn't operating yesterday. I don't know what the source of it is. It is what it is, though. So either the changes I made to the radio have suddenly allowed this radio to do this, make this noise, or there's something different going on today externally. Can't be sure. It's really receiving good. Hey, let's try shortwave. Right. I checked the shortwave band just before I started this morning. Nothing particularly interesting going on.
Because the family's so strong there, the hospitals can't run you out. They wouldn't have any business. So we moved right in the room with Rick and we stayed in there. And the things they'd already done to him were so awful. It just tore my heart a bit. Because they said they couldn't give an anesthesia because they wanted a perfect test result, they started needling it back, went into his hip bone, his age both. Did a bone graft, took out marrow from his bone.
Okay. Wow. Okay. So that would be essentially a local shortwave. That would be from southern United States, probably. Just one station. Yeah. Okay, so we'll go up around 11 now. 11. Get up in here. No. Yeah, this is what it sounded like on my other radio. Nothing. Yesterday may have been a special. May have been like an opening. 15 megahertz. Oh, what's that? What? There's somebody there. So I'll tell you what I think that is. That gravelly sound there. If you look at these capacitors, they have spring-loaded grounding techniques. Just make sure I don't get a shock here. This piece here, let me point at it. This piece right here, this son of a gun. Bad camera work, Jim. There we go. That piece right there is actually a spring pushing on the shaft down here. I can kind of move it a little bit. Those become dirty in there, and there should be a bunch of them. One there, one there. They probably lose a little bit of tension maybe, and there's probably one back here too, or something. No. Okay, there's something interesting here too. These double-teethed plates here. Okay, so this is an anti-backlash system. It sounds like my camera's the source of the interference. I don't think so. Yeah, so the anti-backlash, when you have gears meshing, okay, there's always a touch of this. So if you make your gears so there's none of this, then they won't mesh right. There needs to be a bit of play in them. So what they do is, instead of having one set of gears, they have another set behind it, matching it, but pulled a bit over. It's pulled over by a spring. So when the next gear comes in now, instead of coming in I don't have enough hands to show this. Instead of coming in on one, it's coming in on two that are pinching together because of that spring. So it comes in and it's tight. There's no play. So as you tune the radio, this terribly annoying thing where you tune it and when you let go it seems to just relax a bit. That's called backlash. It'll drive you nuts trying to tune a radio. Another way to defeat backlash, if you don't have the special gearing, and most radios have a string and really kind of wide open for backlash, is to make sure this is lubricated so it's turning very freely. And then and there's not as much back to lash you after that. So I'm just going to put a little WD-40 into those spots and in the bearing here. Find out if I'm telling the truth about this. Just a little wee bit. Not much at all. And I would like to get it now. This is either geared shaft or slip clutched shaft. Let's see if we can get in there and get a look and see which one it is. Is it gears or is it a slip? So a little hard to see here. You can actually see the spring that's pushing the geared plates. I just turned the volume down. Maybe in this way. It's just there's no easy way to get in here to see what is to be seen. There's the shaft. I guess the slip would be on the back part here. Maybe, I think it's geared. Yeah, I think I can see it here. Okay, hang on while I adjust the focus. There, okay, so we're looking, we are actually looking right at it now. That's a gear. That's the gear I was talking about with my fingers. Come on, don't lose it. What happened? Okay, there it is. Well, if I reach the end and it locks, yeah. Very hard turn. I get some lubrication in there somewhere. Something is really hard to turn. Wait a second. Yeah, there I am. I can see it now. Yeah, I'm turning the little tiny gear, and that's driving the bigger gear, which is driving the capacitor cores. Okay, I gotta spray some lubrication in there because you know you want these radios to feel really comfortable when you're tuning them. The tuning should be nice and smooth. It sure isn't in this radio. Okay, so there's a bearing. Right back in here. Another spot. My little knob's going off there. Okay. Give it a good blast here. Oh, that seemed to loosen it up quite a bit. Oh yeah, it's loosening right up now. So that was the spot. It's hard to tell when you're turning one of these as a system of things, and you can't really tell which thing might be causing the... that's a lot better. Now, I heard some scratchy sounds. Let's turn it up again. It's not scratchy. It's a station. And you're whipping past the station that's fairly powerful, and the radio's AVC is being activated because you're getting a short period of detection of a signal. Those changes, when they happen and you're doing this stuff, can start sounding like scratchiness rather than what it really is. Unfortunately, that interference is so heavy. That's interesting. No idea why that helps, but it did. So that was up around 15 megahertz. That. So the scratchiness is disappearing. There's a little bit there. Now that could be plate rubbing. Well, I think it was just a little bit of dirt, and I just wore the dirt off here by doing this. No more cracking. I wish I knew what that interference was. So I think what this radio needs now is an alignment, and then a final judgment. I mean, we're pretty much there already with it. I think I'm going to want to pull all these tubes out and clean the dust off them. And just generally, there's a lot of dust here. Clean up all this dust too before we go any further. I've got a light bulb to change here. And this one is pretty accurately lined up here. And that's with the filament lined up. I think this is the wrong size bulb in here. I put a 47 with a long glass, has a long glass bulb, and that's why it's burned out the paper here. I think this really needs a shorter bulb too. But it looks pretty good, eh? Let me do that. I should do that. It's getting the light right into the glass. Good. Yeah. Okay. Kind of hanging on here for no reason. So, okay, that's it. We'll see you on the next video. Thanks for watching.